lasted exactly 24 hours, but a day in Antarctica took 34 hours. The Earth would physically rip itself apart. Yet, our Sun does exactly this every single month. At its equator, it spins in 25 days. But at its poles, 35 days. This physical impossibility is happening right now, 93 million miles away. Parts of the Sun are literally outrunning other parts. It completely defies how solid objects behave in the vacuum of space, twisting its internal core into billions of miles of coiled tension. Today, solar physicists are deeply divided on exactly why the poles are dragging so far behind. How does a single, massive star rotate at drastically different speeds without tearing itself to pieces? To understand why this is so baffling, look at Earth. Our planet is solid rock. From the equator to the North Pole, everything rotates together, in lockstep. If it didn't, the planetary friction would vaporize us. But the Sun isn't solid. It is a gigantic, boiling sphere of superheated plasma. Scientists call this phenomenon differential rotation. But here is where things get strange, and stay with me here, because what you are about to see changes everything about how we understand our place in the solar system. We are unlocking the universe's most closely guarded secrets here every single week. If you want a front row seat to the cosmos, hit that follow button right now. Because what I am about to reveal next, the invisible force acting inside the Sun, is exactly why thousands of people are joining Deep Space Secrets every single day. The mystery started in the 1600s when Galileo first tracked sunspots moving across the solar surface. But the real breakthrough happened in the 1990s. The SOHO spacecraft peered deep inside the Sun using sound waves, a technique called helioseismology. Scientists at Stanford University expected the interior to spin uniformly. Instead, they found a violent, churning boundary layer 130,000 miles deep called the tachyon. And what was happening inside that layer completely shattered our cosmic models. Here is the leading explanation. Imagine stirring a cup of coffee, but the center spins at a completely different speed than the outer edges. The Sun's massive heat travels outward, mixing with the star's rotation to create immense Coriolis forces, like hurricanes on Earth, but on a cosmic scale. This forces the plasma at the equator to accelerate, while the poles drag behind like thick molasses. Astrophysicists call it a fluid dynamical masterpiece. It perfectly explains the time warp. But it creates a terrifying side effect. Here is where it gets crazy. Because the equator is spinning 10 days faster than the poles, the Sun's magnetic field lines get stretched, twisted, and tightly wound up like a rubber band. Eventually, that rubber band snaps. But recent data from the Parker Solar Probe suggests we might have it backwards. What if the magnetic fields are actually causing the differential rotation, rather than just being a result of it? Science is currently locked in a heated debate over this exact chicken or egg paradox. So, which side are you on? I genuinely want to know what you think. Is the Sun's boiling plasma ocean driving the magnetic fields, twisting them until they break? Or are these massive magnetic forces acting like invisible puppet masters, physically slowing down the poles of our star? Drop your theories in the comments below. Plasma, magnets, or something entirely undiscovered? I will be reading and replying to the most mind-bending theories, so let's debate down there right now. This isn't just an abstract space puzzle. This affects human survival. When those twisted magnetic bands snap, they hurl billions of tons of electrified gas toward Earth. A direct hit from a massive solar storm, like the Carrington event of 1859, could wipe out global power grids, destroy our satellites, and send humanity back to the dark ages in an instant. By the end of this decade, understanding why the Sun's poles drag could be the key to predicting these catastrophic storms before they happen. Our modern civilization literally depends on solving the physics of the Sun's strange, uneven heartbeat. But there is massive hope on the horizon. Scientists around the world are now using groundbreaking technology to finally pierce the Sun's veil. The European Space Agency's solar orbiter is currently flying out of the planetary plane, aiming to take the first first ever high-resolution images of the sun's poles. In the coming years, as these probes beam back classified level data, we might finally map the deep currents beneath the surface. The pieces of this 400-year-old puzzle are finally falling into place, proving that our oldest, most familiar star still holds profound mysteries. But this bizarre 35-day polar rotation isn't the only impossible thing happening in our solar system. Have you heard about the perfect, massive hexagon storm raging on Saturn's North Pole? Or the terrifying fact that our moon is currently rusting, even though there is zero oxygen in space? We are diving into both of those incredible mysteries next. Thank you for exploring the cosmos with us today. Remember, the star that gives us life is far more complex than we ever dared to imagine. The universe is full of secrets, and we are just getting started. Stay curious, keep looking up.